Chapter 3, Lesson 3 reviews the slopes of lines, and then we look at relationships between the slopes of parallel and perpendicular lines. Okay. Slope is the ratio of the change along the y-axis to the change along the x-axis between any 2 points on the line. We also call slope the rate of change. Okay. Slope, when we talk about slope and talk about finding slope, we talk about finding the rise over the run, which is the change in the y values divided by the change in the x values. We can find slopes both graphically and algebraically. Now, some characteristics of slopes. Okay, a line with a negative slope goes down as you move from left to right. And so when you count the slope between 2 points, rise over run, so here's a point up here, I would count down 2 units and right 4 units. Moving down goes in the negative direction, so that's -2. Moving to the right is in the positive direction over 4. And -2 force reduces to -1/2. So as you can see, the slope is negative, and the line also goes down as you move from left to right. Moving on to the picture on the right, this is an example of a positive slope. If you follow the line as you move from left to right, positive slopes go up. And then when you find the slope of the line by counting rise over run, both the rise and the run should move in the positive direction. So here I'm going to go up 1, 2, 3, 4, and to the right 1, 2, 3, 4. Up and right are both positive. 4 divided by 4 can be simplified to equal 1. So notice the slope is positive. Now, even if I start at the point above and I counted left 4 and down 4, -4 divided by -4 is a positive 1. Two special types of lines are horizontal lines and vertical lines. Horizontal lines have a slope of 0. So here's an example of a horizontal line. I do not move up at all to get to the other point. Therefore, my rise is 0. And the run is the distance between the 2 points, which in this case is 2 units. 0 divided by 2, or 0 divided by any number, is always 0. Okay. On the right side, we have an example of a vertical line. Vertical lines always have slopes that are undefined. Okay. The reason they're undefined is because we never move to the left or to the right, and therefore my run is always 0. And any time you have 0 in the denominator, it makes that specific value undefined. So here are 2 points. I count up 2, so my numerator is 2. I do not move left or right, so the denominator is 0. 2 divided by 0 is undefined. Okay, the reason it's undefined is we have a fraction as part over the whole. If our whole is 0, okay, then we have nothing that we can take a part of. How does this apply to Chapter 3? Well, Chapter 3, we have focused on parallel lines, and in Chapter 1, we also looked at perpendicular lines. Okay, there's a special relationship between the slopes of parallel and perpendicular lines. Okay, on the left, we have an example of parallel lines. Okay, and if you find the slope of each line, for line A, I'm going to count up 2 units and right 1 unit, so it has a slope of 2 over 1, which simplifies to 2. The slope of line B, go up 2 and right 1, also has a slope of 2 over 1. So what we know is that parallel lines always have the same slope. And then we could state using symbols that line A is parallel to B. On the right side, we have an example of 2 perpendicular lines. Perpendicular lines intersect to form right angles. So line C and line D are perpendicular. If I find the slope of line C, I'm going to move down 1 and right 2. The slope is -1/2. The slope of line D, I will go count up 2, right 1. The slope is 2 over 1. So I would say line C is perpendicular to D. Now, how do these two slopes compare to each other? Well, slopes of perpendicular lines are opposite reciprocals. Okay, opposite numbers have different signs. So notice the slope of line C is negative, the slope of line D is positive. They are opposites. Okay, they are also reciprocals of each other, and reciprocal is when you flip a fraction. So the slope of line C was 1 over 2. If you flip it, it becomes 2 over 1. Okay, so both of these slopes are considered opposite reciprocals because they have a different sign. One is negative, one is positive, and the fractions are flipped. In example number 1, it says determine whether line AB and line CD are parallel, perpendicular, or neither. Graph each line to verify your answer. Okay. The first thing that I'm going to do is plot points A and B. Point A is 1, 3. So starting at the origin, I'm going to count right 1 and up 3 units. This is point A. Point B is negative 2, negative 5. So from the origin, I count left 2 and down 5. I'm going to connect my 2 points together with a straight line. I'm going to use my ruler to help me draw straight lines. Okay. Now I'm going to find the slope of line AB. So starting with point B, I'm going to count rise over run. I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, and to the right 1, 2, 3. So line AB has a slope, rise of 8 and a run of 3. So it has a slope of 8/3. Next, I'm going to plot points C and D. Point C is negative 6, negative 2. So I'm going to count left 6 units and down 2 units. This is point C. Point D, I'm going to count right 8 units and up 3 units. It's point D, and I'm going to connect the points together with a straight line. Okay. Now, looking at the graphs, they do not appear to be parallel, and they really don't appear to be perpendicular. But we're going to verify this by finding the slope of line CD. So starting at point C, I count up 1, 2, 3, 4, 5 units. So it has a rise of 5. And I have a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So line CD has a slope of 5/14. Okay, these two lines are not parallel because they do not have the same slope. They are not perpendicular because the slopes are not opposite reciprocals. Therefore, these two lines are neither parallel or perpendicular. Okay, I would like for you to try the next example, and we will check that answer in class as well as complete 3.4 notes.